So we're going to look at basically using FME for purely attribute data here. And in the first case, we're going to look at address cleanup. So the problem that Andrew had is that he was working for a campaign, electoral campaign in France, and the data came in, and he had to put it into the Nation Builder program, and it's a very defined schema, and you have to have everything in the right order. And the attributes were all over the place, and they were kind of mixed up. So the problem was, how do you define, how do you relate a specific data value to a schema column or name and associate that. So what we did here is we just used a few simple transformers. We just used a string searcher, attribute splitter, and attribute manager. And based upon those things and using a regular expression, we were able to first find a key pattern within the data, within the strings themselves. So what we did is found the postal code pattern in there, and then what we did is applied that pattern to a pattern that we knew in the schema. So then we can move everything, shuffle everything into the right category. So it's really where you don't have defined, it's fuzzy string matching essentially what you're doing here, and then you're pushing everything else into the right category. And the nice thing about this is we're using CSVs, and CSVs are basically dumb XML, which is nice because then you can push them around a lot. So yeah, essentially that's what we did. So we had a starting off area here where we're trying to find the key elements that we could match up and say this is where this sits in the whole spectrum of things, and this is where it should sit, and that's what the regular expression was doing. And then from there, you can filter out into certain paths and push everything into the right area so that it properly matches the schema, and you can upload it without any issues. The other nice thing about having something in the front here where you're looking at a regular expression to bring out those key elements is that each path that you put it on, if you have a problem with it and your fuzziness, it defaults, what you're going to have is duplicates, and those are really easy to parse out at the end because you can put them in the duplicate finder and then parse them out and decide what you want to do with them, or go through another refining process after that. So this is the data, and this is an example here. So everything was mashed up in the wrong area. There are a lot of blank values where there shouldn't be blank values, and to use it like a test filter on these wouldn't work out as well because you have really defined, so the regular expressions help push everything into where we want them to be. And the other thing that Andrew found is updates. What do you do in that case? And the feature merger was a good option here. I think most people think of a feature merger as something where you're merging spatial attributes together, but it's really a useful tool if you just want to test do a comparison. So you can attach few onto each other and really do fuzzy string matching and see how the variance between the two, if you cascade them down. In this case, we just did one, and then we figured out, these are ones we have to review. These are the ones that match up. So that's another case that most people don't think about using feature merger, and I think that's a key point that Andrew wanted to put forward. So I think there's a lot of applications for this. I know Andrew was saying that Ireland is revamping their whole postal system, and there's a lot of cases where there isn't the same consistency that we see in North America. Some are over the hill behind the pond is the address, and other ones are more formalized to what we expect them to be. So I think there's a huge variance in the data, and I think if we can use FME to find the patterns within the data and then build the schema around those attributes, around those values, that can be quite useful. So yeah, essentially the metadata is king, and that's what he's trying to, I think, put forward. You really need a schema, but I think the nice thing about FME is you don't have to have the defined schema set beforehand. As long as you know what the schema should be, you can use the values to help develop the schema and then put it forward, but you still have to know your data beforehand. And I think when we were looking at a lot of other applications where you have to fit everything into a tight little box and everything has to be in the right spot, FME is really good at doing that, taking really bad data if it's flexible enough and putting it into the right area. So that's basically the talk here. Pretty short, But if anyone has any questions, I'm just trying to paraphrase. I think some of the other applications of this, in my personal experience, is with CSVs, we're doing feature tables, which means they're read really quickly. So I think there's an opportunity here to really do fast cleanup where there hasn't been in the past. Yeah.
I work a lot with postal codes that come from surveys and other sources. And I'm wondering, did you have to put in any filters for postal codes that are not real? People like to put in fake postal codes for some reason.
Right. No, we can look for patterns in the postal code. So we can say, postal code is going to be number or letter. So you can do things like that with the regular expression. You can filter anything out that doesn't fit a format for it. You can also, if you had a rough idea, you could definitely pass it through a geocoder and then see, does this actually match up with where they are supposed to be? And then you can validate it that way. It's one option, but it wasn't part of this one.
How did you solve street names which have numbers in it? In the beginning or in the end of the street name? Or don't you have these in England?
In this case, we didn't have a lot of those cases in here when it was before or after, but for inconsistent data, essentially, we just looked for patterns again, split it up into its most basic elements, and then if you had an idea of what the structure should be afterwards, put it in. You can also use, if you have a comparison data set, fuzzy string, you can match it up and see if it matches most of the other values, and if it's a swap of them, before or after, then you can do that. So in some cases, you're saying that the address should come first, in other cases it should come second, or it's just a mix-up in the data that it came second.
Everything is mixed.
Yeah.
You can say the house number may be systematically first or behind, but if there's let's say that you first have the house number and then the street name.
Yeah.
But if the street name has a number.
Right.
You're starting with a number, then you have a problem.
Right, but you can still use a regular expression to find that alphanumeric, or the character in there, and then you can sort it out that way. And there's definitely patterns that you're going to see in the data that you can pull out through these regular expressions and define how you want to sort it all out, and especially if you can break it into the most basic elements, I find. So yeah, there's definitely challenges. It's not perfect. I looked at Ireland's data, and it is a complete mess. So there's ways to do it. It just gets a lot more complex as you break down each circumstance. Yeah.
Okay. Anybody else? Hi. I might have misunderstood, but I'm just curious why, if it was a French electoral campaign, it was targeting UK addresses. Is that right?
No, sorry, it was French addresses. The program was Nation Builder in UK, so it was like a British company that was doing it. I can't really speak to what the work was. I'm sort of just presenting on his behalf here, but we can ask if you like, yeah.
Okay. Great. Thank you very much, Richard.